Our last lesson for chapter 4, this is a quick little chapter, 4.8. I'm going to double check. I'm sure this is the last one. We go to, yep, the unit test after that, or chapter test. So 4.8 is kind of cool. It's taking everything we've learned and really combining it back with coordinate points, which was chapter 3. And so using equivalent ratios or rates and graphs to solve problems. So we actually take our rate and the top and bottom term become our coordinate pair on a graph. And we go from there. So I'll show you some examples. So a car travels at a rate of 50 miles per hour. Use equivalent ratios to graph the distance that the car travels over time. Graph time on the x-axis and distance on the y. And that's normal. If we're doing something with time, they usually want time on the x-axis, if you can remember that. All right. So they want us to write and graph the equivalent ratios. Easy ways to set up your table. Again, all you have to do is kind of draw this line and then draw your up and down. You don't have to do this fancy chart. My unit rate was 50 miles per 1 hour. So times 2 times 3 times 4 times 5. So 50 times 2 would be 100. And same thing down here. So 1 times 3, 1 times 4, and 50 times 5. 5 and 5 is 20. So 25, 250. So that's how I didn't go through all over here, but you can fill this in. All right, so 100 miles in 2 hours. So I'm using that rate. Now I'm going to take those. And remember what they said, time is my x. So time, label it here, x. All right, they want time to be the x, so distance is going to be your y. Because remember, it's always x, y. X has to come first. So really important that you keep it straight which one of the two, which is x, which is y. And now I'm just going to take these as a coordinate pair. So 1 is my x, 50 is my y. Coordinate pairs have the parentheses around them. 2 goes with 100. 3 goes with 150. 4 goes with 200. And 5 goes with 250. And then we take those and we plot them. Okay, so here's my coordinate pair. Coordinate plane. Time is on my x-axis. Distance on my y-axis. You have to decide on the spacing sometimes. They did it for you here, but really the spacing up here can also be your spacing here. So 1, 2, 3, 4, 5 counting. So 1 block, 2 blocks, 3 blocks. And then skip counting by 50. So 50, 100, 150. That's always an easy way to do this. And so we're going to use these ordered pairs to graph the car's distance over time. So they already did 1 and 50 for us. 2 goes with 100. 3 comes to 150. 4 went to 200. And 5 goes to 250. So now what you can do is you want to draw a straight line through there. Okay? And you can use a ruler. And then with doing that, you can extend it and you can read off a graph. So if I went 8 hours, how far would they have gone? So I come to the 8. I come up, that's where it intersects the line, so read that back over to here. So 400 would be my answer there. All right, so we're going to do a couple more examples like that of the graphing on the next pages. So on page 256, we have an example at the top. During a heavy rainstorm, the waters of the Blue River rose at a steady rate for 8 hours. The graph shows the river's increase in height over time. Remember, time is on the x. This is going to be my height. Use the graph to complete the table of equivalent ratios. How many inches did the river rise in 8 hours? So here's the deal. They don't give us any information in here, number-wise, besides 8 hours. That's all they tell us. They're not giving us a unit rate. They're not giving us any rate. They did tell us it was a steady rate. So we have to use the graph to get our information. And this is the key one right here. Okay, this 3 with the dot with the 3 and the 1. That's my unit rate, 1 hour. So on the graph, x coordinates represent time in hours. And the y coordinate represents a river's increase in height in inches. I'm getting that from this information here. And the ordered pair 1, comma 3 means that after 1 hour, the river rose 3 inches. And that's my unit rate. So I can quick do my little chart, or I can read them off of here. So 2 goes with 6, 4 goes with 12. Notice they didn't go, they want 1, 2, 4, 6, 8. So they kind of changed how they're skip counting. So be really careful of that. They might not always come across evenly. 6 goes with 18. And my 8, if I come up and I read it off my graph, 24. All right, now we should make sure that we read those right. So if this increase, this was times 2, 3 times 2 is 6. 1 times 4, 3 times 4 is 12. Times 6, 3 times 6 is 18. So it looks like I got my numbers right. And our question was 8 hours, so right here. So in 8 hours, the river rose 24 inches. And last thing I'm going to do here is page 257 and 1, 2, 3 at the top kind of all go together. So a redwood tree grew at a rate of 4 feet per year. So that's important. They just put it in that little sentence up there. Use the information for 1 through 3. So first off, complete the table of equivalent ratios for the first 5 years. So it was 4 feet in 1 year. So 1, 2, 3, 4. They wanted the first 5 years. So 2 times 4 would be 8. 1 times 3, so 4 times 3 is 12 times 4, and 4 times 5 is 20. Now take that, make them the ordered pairs. Time is my x. I'm going to label it x, y. So 1 goes with 4, 2 goes with 8, 3, comma 12, 4, comma 16, and 5, comma 20. Then they want me to come over here and graph it. So notice things are not labeled. I'm going to have to do that. I'm just going to use these numbers right here. So time, this is 1 year, 2 years, 3, 4, 5, and so on. And then I can skip count these blocks by my 4. So 4, 8. Remember that 4 is the line, 8 is the line, 12 is this line, 16 and 20 is that one. And then I need to plot them. 1 and 4, 2 and 8, 3 and 12, 4 and 16, 5 and 20. You should always have a straight line on what we're doing right now. If you do not have a straight line on your graph, something's wrong. Okay, you'll eventually get to curved graphs, but not this year in 6th grade. And so there I have it. So if I wanted to, this is called extrapolating. Extrapolating, I'm going to write down extrapolate. That's basically an estimate, or like when you kind of extend your graph out to find more information. So if I want to find out how tall the tree was in, let's say, 8 years, what's the height of my tree? So here's 5, 6, 7, 8. So here would be my 8. And so I'd come up, and when I hit the line is where I come over. And remember, I skip counting by 4s, so 20, so this will be 24, 28, 32. So 32 feet in 8 years. Does that make sense? 8 times 4 is 32. Yes, and it should, match up like that. All right, you give it a try. Again, sometimes you're going to get information here. Sometimes you're going to be given the information just off the graph, and you have to read that to fill in your problem.